Hi, this is Jason Molesky. In this example, we'll take a look at finding probabilities involving the sample mean. Now recall that the height of young women follows a normal distribution with a mean of 64.5 inches and a standard deviation of 2.5 inches. In this example, we'll find two probabilities. First, we'll find the probability that a randomly selected young woman is taller than 66.5 inches. Then we'll find the probability that the mean height of an SRS of 10 young women exceeds 66.5 inches. In both cases, we'll be sure to show our work. So recall, when we're solving these problems, we want to perform three steps. And step one is to state our distribution and the values of interest. Well, let's let x be the height of a randomly selected young woman. This random variable follows a normal distribution with a mean of 64.5 inches and a standard deviation of 2.5 inches. We want to find the probability that x is greater than 66.5 inches. Now notice in our population distribution, we can sketch a nice normal curve and shade our area of interest. We also have the sampling distribution plotted here as well, and notice how it's much more narrow and taller than the population distribution. That's going to come in kind of handy later on. So to perform our calculations, what we'll have to do is first standardize our boundary value. So we'll find the z-score for 66.5 inches, and it turns out to be 0.80. Using table A, the probability that x is greater than 66.5 inches is the same as 1 minus 0.7881, or about 0.2119. So to answer the question, the probability of choosing a young woman at random whose height exceeds 66.5 inches is about 21%. Next, we want to find the probability that an SRS of 10 young women will have a mean height greater than 66.5 inches. Well, we know the mean of the sampling distribution is 64.5 inches. Now what we'll have to find is the standard deviation. Checking our 10% condition, we see there are at least 100 young women in the population, so the standard deviation can be found by taking our population standard deviation and dividing by the square root of our sample size. In this case, 2.5 divided by the square root of 10 gives us a sampling distribution standard deviation of 0.79. Notice again that sampling distribution has a much more narrow distribution than the population itself. Now, to find the actual probability, we'll perform our calculations, again finding the boundary value, and in this case we're finding the standardized score of the boundary value in this distribution, and notice it's going to be much greater than the boundary value or the z-score in our original population distribution. That is, the boundary value is much higher above the mean or much farther above the mean in terms of standard deviations in the sampling distribution than it did in the population. Specifically, 66.5 minus 64.5 over 0.79 gives us a z-score of 2.53. Using table A, we find this probability to be 0.0057. So it's very unlikely that, less than a 1% chance, that we would choose an SRS of 10 young women whose average height exceeds 66.5 inches. For some additional practice with finding probabilities involving the sample mean, try exercise 55.